Welcome to breadboarding. In the previous video we managed to get our CGA video controller working with the video attributes. So here's a test pattern that we produced which has got a repeating pattern by driving the video attributes from the address lines for the cathode ray tube controller. So you can see that we're feeding the character generator input here is coming from the address line to the CRTC, as is also the video attributes input into here. So in this video what we're going to be doing is looking a little bit more detail of testing the video attributes. So things like the blinking, the 40 column mode as well as the 80 column mode. And we'll also be looking at the control mode register and the status register to make sure those are working. So this is the pattern that was produced in a bit more detail, and we'll be looking to see if we can repeat the pattern that I showed from the version 1 of the series, where we had this pattern with the thinner band, so we'll be looking at that. This is video 15 of the Breadboard PC 8088 version 2 series. And in the previous video what we got was a lot of this logic here that was previously in separate PLDs, all working in the one PLD with our CGA control and CGA status registers. We've also added the CGA color register, although until we use the graphics modes we're not really going to be able to test that. And this has all been put together in one ATF1508 complex PLD, which has got up to 128 macrocells. So what we're going to be doing during this video is testing the CGA control mode port, status port, and we're also going to be checking to see that when we feed different attribute and character values in, that we're actually getting the expected output. But first of all, what I want to do is to just have a quick look at the fonts. Now, when we were looking at the fonts or the character sets that we're going to be using for the CGA card, we initially used the wide CGA one, which I'll just show you on the next page. So this is the test pattern using the wide CGA fonts that we've looked at in earlier videos. And if we just have a look at the schematic diagram around the character generator ROM, we can see that one of the address lines here is used to switch between the wide font and the thin font. And there's also another one of the address lines is actually used to switch between CGA when it's grounded and the VGA 16-line fonts. So what we're going to do first of all is just to switch this from the wide to tie this to 5 volts so we can look at the thin fonts. This is the wide. Now this is the thin, and if we toggle back and forwards between the two, you can see that basically what happens is the vertical lines have 2 pixels using the wide font and only 1 pixel using the thin font. And I think probably for CGA using modern monitors and modern video capture devices, I think probably the thin font looks better. Now, one of the other things I did talk about but I hadn't actually done was it is possible for us to configure the upper 4K of the EPROM here to have the VGA 16-line fonts. Now the only issue here is that the CGA fonts use 8 raster lines, and because we're using a VGA compatible output but using CGA sort of technology here, what we do is we ignore the RA0, the row address 0 line, so effectively we double up every line. But in order to use the 16-row VGA fonts, we actually need to change this so that we're using RA0, 1, 2 and 3, and then all the CH0, CH7 all need to shuffle along, and in fact we need to move CH7 to the wide thin here, and we need to shuffle around the other CH5, CH6 up one. So what I've done is I've actually already done that. We also need to wire in the RA0 line from the CRTC. So if we wire in the RA0 line as well, then what we can do is to actually get the VGA fonts. So if we just have a quick look at the Frapped tool that I talked about in earlier videos, this allows us to look at the character sets and the fonts. So you can see on the left here we've got CGA thin F08. This basically means it's 8 lines, and you can see that the vertical parts of the character have only got 1 pixel. And if I then look at the VGA 16-line one, you can then see that the verticals of the characters are now 2 pixels wide. But in this particular case, because the VGA font has 16 lines available for it, we have 2 blank lines at the top and 4 blank lines at the bottom. So it means that the characters aren't quite so jammed up together. And when we look at the output, you'll be able to see that the VGA fonts look a bit cleaner than the CGA ones. So here's the thin CGA font. You can see that the characters are using 7 out of the 8 available lines, and because we're doubling up our CGA output here from 200 lines to 400 lines, then every line is doubled up. So we're using 14 out of the 16 available lines for the characters. Then if we switch on to the configuration using the VGA character set, with those changes identified in the KiCad schematic, you can see that the characters look a little bit better here, and there's more space between the lines, just because these characters are only taking 10 lines out every 16, so there's a bit more space between the characters, and I think this generally looks a lot better. So although we're trying to produce something which is CGA software compatible, I'm going to be running with these VGA fonts since we're outputting 16 lines per character anyway, and it doesn't make any difference to the software at all. It just looks a little bit neater. And if we just toggle backwards and forwards, you can see that really it looks a lot better with the VGA ones. However, if you're trying to produce retro output which is compatible with the original CGA card, we can always switch back to this mode should we want to. So what we're going to look at now are the status and control registers. We'll just have a quick look at the status register to start with, because this is the simpler one. So this is the status register information from the original CGA technical documentation produced by IBM. And there's only really 2 bits that we're interested in. Bit 1 and bit 2 are related to light pens, and light pens only really work with CRT type displays where the electron beam is scanning across the screen. And bit 0 indicates that the regen buffer memory access can be made without interfering with the display. And what that basically means is that this is during one of the blanking periods, and that we can update the video RAM without actually causing any snow interference. And the bit 3 indicates a vertical sync period. So this will be true during the vertical blanking period. So in general, the blank DE will actually indicate when we get to the end of each horizontal line, and it will also indicate when we are in the vertical synchronization period. And we'll be able to look at some of the signals coming out of the CGA video controller to see whether or not our status register is reflecting these values. I should also say that bit 1 is going to be set to 0 by default, and bit 2 will be set to 1, and the higher bits, bit 4 to 7, will also be set to 1 to be compatible with the original CGA card. So the mode control port is probably the more complex one, and we covered this at a high level in the earlier videos. What this does is switches us between the various video mode, the graphics modes, text modes, the 40-column and 80-column modes. And if we have a look here, you can see that the way how this is represented, we've got the least significant bit on the left here, most significant on the right, which is probably not the way we normally would think about things when looking at bit values and byte values. And we covered what the various things mean. So we've got blink enable, our high-res 640 black and white or 2-color graphics mode, video enable, which when this is set to 1 enables output, when it's 0 then it stops output from occurring. If we want to turn off the composite color, so we just get black and white grayscale values, that's the BW value here. The graph is to enable graphics modes, and the high-res switches us between the 80-column mode and the 40-column mode. So if we have a look at the values in this table over here, we're going to be using this table here for determining the test software. So all I've done is taken this, and we've got basically the bit here is the enable blink. And we're not going to be using the graphics mode. So you can see here that video enable, to start with, the first test we're going to have video enable turned off. So we're not actually going to see anything to start with. Then for all the other tests, we have video enable is enabled. This test here with blink on, we're going to enable the blink bit, and blink is going to be disabled for the rest of the time. You can see that the high-res bit here, which normally switches between 80-column mode and 40-column mode, this is actually set to 80-column mode all the time, except for when we're looking at the 40-column output. And then there's another row here where the test is actually going to be polling the status register for a period of time, so we can actually see whether the status register indicates when the display enable and the vertical sync periods are actually occurring. So in order to test this, I've updated the CGA Test program. CGA Test 3 now is based on the earlier ones they showed in the previous video. And what this now does is it outputs the test on the display. So it's got test 3, and then we actually have an individual step number. Now to start with, it will output the CRTC registers. So it starts with the 80 column mode by default, initializes a video palette as we've done previously. And then to start with, we're actually disabling video enable to start with, and we're clearing a screen. The clear screen will come in once we've got some video RAM. So then we're going through a number of tests. So these tests actually tie back to the table I showed previously. So to start with, we'll be enabling the video enable bit, and we'll just have the high res bit set. So this should just give us our 80 column text mode. Then we're going to be enabling the blink bit. Then we're going to be polling the status register. So what we do is we just go into a loop for 64,000 times, where we just poll the status register. And because that will be going on the data bus, we can then just see what is going on the data bus from the status register there. Then in fact, for the next test, we switch into the 40 column mode. And because the 40 column mode has different timings for the cathode ray tube controller chip, so we have a different loop here to read a different table. So this reads from the CRTC tab 40 for the 40 column mode. And then we set the CRTC table back to the default again before we finish the test. And down the bottom here, we can see that now, in addition to the standard 80 column CRTC table, we now have the values for the 40 column mode as well. So just need to assemble that. And then we're going to switch on the Breadboard PC. We're just going to load that down onto the Breadboard PC. So this is our CGA Test 3S rec. I just need to go into the monitor here and set the extra segment to 6000, code segment 6000, load. We're just going to send the file down. So just now going to look at the top-down view with the VGA capture on the right-hand side here. Now we're going to do is to run that and check to see what sort of output we have. So that is with video disabled. So now we have the test pattern output, and I think that's very similar to the test pattern output we had previously. Now we've got blink enabled, so we can see there's some text blinking there. Then this is the grey mode, the black and white mode. So the colours have been replaced by a more limited number of grayscale values. And this is turned it back. And then we're going to switch to 40 column mode. So that's now showing the 40 column characters, then switch back again. So this is just showing that the test program seems to be working, and we seem to be switching between the various values. But in order to really see what's going on here, what we need to do is to have a look at all of the signals using a logic analyzer. So what I've got here is we've got the logic analyzer set up to look at the vertical sync, horizontal sync, and display enable outputs. So these are the signals which are going to be sort of accessed via the status register. We've also got the P0 to P4 output for the input into the video digital analog converter. We've got the main CPU data bus here, so when we're reading the status values and we're writing the control register values, we should be able to see the values on there. We've also got the CGA control chip select line, the CGA status chip select line, and then I've also hooked up these outputs are actually on the pins on the complex PLD for the various status register values. So things like the high res mode, black and white flag, and the blink enable, for example, we should be able to see those values directly. So what I'm going to do is to run this up again, and we're going to record this. So what I'm going to do is to go into the monitor and run up the program again. And all we need to do is to press a key between each of the tests. We should then be able to see where the control register is being written and the status register is being polled. So just waiting for the program to be run. That's finished. And if we just check that the video output looks the same, okay, so we have the same video output there, so that's good. So what we can see here with this output in the logic analyzer is that this is where we're writing the various CGA control port values. And at the moment, what we've also got is the value here has got the status included with it. You can see here at the moment, we've actually got the CGA status value in there. So we'll turn that off for the moment. But when we want to look at the status, then we'll be able to have a look at those starting with a 0. So what you can see here is that we've actually written a 1 there for the first value. And that was where we're disabling the video display. Then the first test is outputting 0.9. And if we just check back to our screen, you can see here that we've got this bit here, which is bit 8, and bit 0, so that is 9. That looks like what we'd expect. And we can see the other status values being set here. And if we scroll down here, we should be able to see that at this period here, then video enable is actually set to 0. Then we enable video enable. Blink enable is enabled at this point in here and then turned off. Then we enable the black and white mode, so this turns off the color output. And at this point here, you can see that the CGA status is then starts to be polled. Now, when we looked at the CGA status, we know that by default, CGA status is expected to be a value F4 when both the bits are low. We expect F5 when bit 0 is high, and FD when bit 0 and bit 3 are high. So what we should be able to see then is F4 is what we'd normally expect, and when we should see an F5 and an FD from time to time. So we've got the F4 there, and this is really where, if we want to just look at where we're reading the status values here, if we go into the analyzer here, we add the CGA status here, then we just search for those with 0 F4. And you can see that this is one of the first ones that we've got. So we'd expect to see 0 F4. We just add these markers here. If we now go up to the top here, then we can see that the horizontal sync and vertical sync, you can see that the vertical sync is only occurring sort of 70 times a second. The horizontal sync occurs much more frequently, so about 31,000 times a second. And you can also see the display enable, that the display enable is slightly wider than each horizontal sync. And if we look at the vertical sync periods, you can see that the display enable blanking period is wider than the overall vertical sync period. So you can see that looking at the display enable actually gives you a longer period of time when the video RAM can actually be updated. But the values that we're expecting is the vertical sync and the display enable. And what that should give us is both the F4 and the FD values. So if we put some markers in here, and we'll move C1 and C2 into this period as well. So this happens to be during where we're polling the status values. You can see down here, this is CGA status. So what this means is during this period here, when we're polling the values here, we should be able to see a value here of FD, which we're seeing. So we see each time we poll during this period here of the vertical sync, we should be finding in the CGA status here, we're finding value FD, 0 FD, so that means the enable for status is low. And we've also got the value. And then if we look at one of the periods when we're outside of the vertical sync and it's just display enable is going to be low, Now, if we look at a CGA status value during this period, we can then see that the value there is 0F5. And then the rest of the time outside of these periods, we'd expect it to be 0F4. This is a period when display enable is high and video sync is low, and in fact we have 0F4. So it looks like the status register is actually returning the correct values that we'd expect, and these are very much related between the vertical sync and the display enable. And if we're using display enable, then that actually would give us a longer period of time to actually update the video RAM during each video frame, and we have a much shorter period of time during each horizontal sync. You'll see here you only get about 6.3 microseconds, so it's not very long, probably only do about one operation for every horizontal line, whereas a lot more time available during this period here. We have about 1.5, 1.6 milliseconds per screen refresh. Okay, so that indicates that that seems to be working. So now let's just go into the full screen video mode, and we're just going to go through testing the blinking and the other video modes. Okay, so this is the output that we had at the end of the last test. And if we now just start our test, we'd expect this to now go blank. So on test 0, now we're going to do test 1, which should just be 80 column mode. And you can see this is very similar to the screen that I had at the end of the previous video. There's a slight difference in that some of the background was alternating between a highlighted background and normal background in the previous video. I have modified some of the rules in the PLD so that no longer occurs. So this is the pattern that we'd expect to see. I'm going to change some of the characters here in a bit so we can see this pattern a little clearer. Now we should also now have blinking enabled. So those attributes where the most significant bit is set, this will be the D7 bit, then this will actually blink the video, so that appears to be blinking. Okay, then the next one will turn it off and then sets it to black and white mode. So you can see here that originally on the CGA card, what black and white mode would do is turn off the composite color when outputting to composite video or a TV monitor. Then it would just show 4 grey values. So I've modified the video palette to only output the 4 grey values. So if we want to, we can output the black and white mode should we want to. Then we're going to do the polling of the status register that I just showed you the outputs of. And then we're going to go into 40 column mode. So you can see here we're now in 40 column mode. We have got some better test patterns. Once we've got some video RAM, some better test patterns we can use to show this, but it indicates we've only got about 40 characters across the screen and still 25 down the screen. And then this will take us back to our defaults. So it looks like those various aspects of the design, so the 40 column mode, the 80 column mode, and the blinking are working, as well as the black and white mode as well. What I'm going to do now is just vary some of the characters so we just can check out the colors in a little bit more detail. So what I'm just going to do now is to have a look at some of the graphic characters that we can use for testing the foreground and background color attributes a little bit better. So if we go down to the graphics characters here, you can see the solid block here is code DB, and then we've also got a couple of other characters here. So DF has half foreground and half background horizontally, and then if we looked at DE, then this is half vertically. So if we use the DB and the DF and the DE, then that should actually give us a couple of characters that we can actually test out the foreground and background colors and check to see that the output is what we might expect. Let's look at the video output. This is the pattern that has the foreground at the top and the background at the bottom. So we can see here in this first block here of 16 characters, we've got the black background. Then following on from that, we've got the blue background, the green background, cyan background, light red background. On to the following line, we've got the pink, the brown or orange, the light grey, dark grey, light blue, light green, light cyan, light red, pink, yellow, and then white. So what you can see there is that by plugging the video attributes into the MA0 to MA7, we're actually showing that the background changes every 16 values. And we can see at the top here that we've actually got the foreground colour changing with every character value there. If we switch this over to one of the other characters, now we're going to switch this to DB. This means we just have solid foreground characters. So you can see here we're just getting the foreground characters going from black, blue, green, cyan, dark red, magenta, brown, light grey, dark grey, light blue, light green, light magenta, all the way through to yellow and white. If we change this value to DE, you can now see that we're only using half the character there, and so we've actually got a different pattern there as well. So just shows that just by using very simple characters, we can actually test out what the different graphics are showing. And in fact, one of the 16 color graphics modes in the original IBM documentation is actually making use of some of these foreground and background for some of these block characters. So what I want to do is just finally check to see if I can produce the original output that I had from the first series. And what I realized is what I'd actually done on the original series is that the video attributes were actually plugged in with the 0 to 7 plugged in reverse. So 0 was plugged into 7 and 7 was plugged into 0. So I'm just going to configure that, and then we'll just check to see whether or not we're getting the output we'd expect. So this is our character test pattern now plugged into the address lines for the CRTC. And I've also then got the attributes just plugged into my dip switches here. So this is just set to F for the foreground, which is bright white, and 1 for the background, which is blue. So I'm just going to now change the attributes now to be coming from the address lines, but the 0 will be connected to 7 and the 7 will be connected to 0. This is now producing pattern very much like the one that we had in the early series. So I'm just going to take a picture of this and then we're going to compare it with the example we had earlier in the video. So here's one of the screenshots from the original version 1, and this just indicates the screenshot from the current version. You'll see the colours are a little bit more vivid, not quite so washed out, and the character set is in fact using the VGA one, not CGA one, but they're a lot similar. You can see that they start with black characters there, going through the various colours. One of the other things I did notice is that we're not showing all of the background colours here, whereas in this one we've actually got the full range of background colours going from various whites, the various lighter colours, the light blue, dark blue, going all the way up to the dark grey. And because the bit order was reversed, so the attributes were mapping address 0 to attribute 7 and address 7 to attribute 0. I'm fairly comfortable now that things are coming out very similar to the way how they were before. So what I'm going to be doing in the next video, we're going to be plugging in the video RAM here. We're going to be removing this complex PLD and the 646 latch we have here, because we're going to merge all of that functionality into a complex PLD here. And that should then mean that we're going to be able to start to do some more interesting test patterns, and we then also should be able to start up the BIOS and actually get the BIOS to send the output to the video screen. So if you don't want to miss out on future videos, please hit subscribe, and if you could hit like as well, just helps to make the videos available to more people. Thanks for watching.